In this video, we're going to see the first derivatives of vector fields. We have the operator Nabla. This Nabla operator, or also called del operator, is taking the derivative, the partial derivative of a function. Let's say we have the function f of x, y, and z. The del operator is the partial derivative of something with respect to x in the I component or in the x component plus the partial derivative with respect to y in the y component plus the partial derivative with respect to c in the c component, or times the unit vector in k, that it means in the c component. If we want to put this in a vector, remember this del operator or lambda operator is a vector. So we can put it as partial with respect to x, partial derivative with respect to y, and partial derivative with respect to c. Now there are three operations that we can do with the Nabla, that are we can have a function and we multiply that function with Nabla. This will give us a vector. So we are passing from a function to a vector. So this will be, let's take the partial derivative of f. So this function is just a function, just f of x, y, and c. Would be, for example, x squared y plus y, x plus 3c x, whatever. This is just a function. If we take the Nabla operator, if we apply this Nabla operator to the vector, to the function, we will have this Nabla f is equal to, you can put it as this vector, that would be partial derivative of f with respect to x, partial derivative of f with respect to y, partial derivative of f with respect to c, or we can put it as partial derivative of f with respect to x in the x component, so times the unit vector I, plus the partial derivative of f with respect to y in the y component, so times in the y component, so times y, plus the partial derivative of f with respect to c in the c component, or times the unit vector k. So this was just multiplying this Nabla vector times f. This is equal to this. So in this example will be 2x. So we first take the partial derivative of f with respect to x. So this part will be, remember that in the partial derivative we took as if we are taking the partial derivative of x, we take as if the y and c are constant, and so we only have 2xy plus y plus 3c. Here now taking x and c as constant for taking the y derivative, the derivative of f with respect to y. So here will be x squared plus x plus 0, and now taking the partial derivative with respect to c will be 0, 0. These are constants for c, and here will be just 3x. So this is Nabla times the function. This is called the gradient of the function.